Have you ever stopped and wondered how AI models just keep getting bigger and smarter without the costs, just exploding into space? Well, the secret might be in this really clever design called Mixture of Experts, or MoE for short. Okay, let's get right into it because this is a real game changer.
So here's the plan. First, we're going to look at MoE like it's a team of specialists. Then we'll cover the big advantages and dig into how its gating mechanism actually works. After that, we'll meet some of the famous MoE models out there and wrap up by looking at the hurdles and the super exciting road ahead.
All right, let's kick things off with the big core idea. Because really, MoE is all about a fundamental shift in how we build an AI's brain. I mean, think about it. If you need financial advice, you're not going to ask every single person in a 100-person company, right? No, you go to the accountant. That's the simple but incredibly powerful idea behind Mixture of Experts. It's all about getting the right expert for the right job. So here's the official definition. An MoE model basically has two main parts. You've got a bunch of smaller expert models. Each one is great at something specific. And then you have this gating network, which is like a super smart dispatcher, figuring out exactly which expert, or maybe a couple of experts, needs to handle the task at hand. And this slide, this really nails the difference. The old way, these dense models, they're that one giant brain. Every single part of the model lights up for every single problem. It's kind of like shouting a question into a crowded room. MoE models, on the other hand, are that team of specialists. They only call up the expert they need. It's just a much, much smarter way to operate. And this whole smarter, not harder way of doing things, it leads to some pretty incredible advantages. So let's break down what you actually get from this approach. Okay, the biggest win here is efficiency. You're only using a tiny fraction of the model, so you just slash your compute costs. We're talking fewer flops. That's just a fancy term for how much number crunching the computer has to do. Naturally, less work means you can train these models faster and get answers from them faster. Plus, the experts get really, really good at what they do. And, maybe the most important thing, you can make the model's total knowledge absolutely massive without the cost going through the roof. It's a total win-win. So, the big question is, how does the model know which expert to call? Well, that's where the gating mechanism comes in. This thing is truly the brains of the whole operation. So, here's the play-by-play. First, an input arrives, let's just say it's a word or a token. The gating network, which is really just another tiny neural network, looks at that token and gives every single expert a score, like how useful are you for this word? Then, the experts with the top scores, usually it's just one or two, they get activated. They do their thing, process the token, and then their answers are all blended together to create the final output. Simple as that. But of course, it's not that simple. There's a catch. What's to stop the gating network from just picking the same favorite expert over and over again, while the others just sit around doing nothing? Well, to stop that, engineers add something called an auxiliary loss during training. You can think of it as a penalty that basically encourages the gate to spread the work around fairly, making sure all the experts stay busy and pull their own weight. Now, this isn't just some idea in a research paper. MoE's already out there in the wild, powering some of today's most powerful AI models. Let's meet some of the stars of the show. This is where you can really see the magic. Just look at these numbers. Mixtral has a total of almost 47 billion parameters, but for any one task, it only uses about 13 billion. Look at Grok 1, a staggering 314 billion total parameters, but it only activates a quarter of them. And then there's DeepSeek V3, which is just mind-blowing, 671 billion total parameters, but it gets the job done with only 37 billion active. It's a massive expansion of knowledge without that crazy runtime cost. And this quote about Mixtral just says it all. Because it's so darn efficient, it can punch way, way above its weight class, performing just as well as dense models that are way bigger and way more expensive to run. It's the ultimate proof that this whole idea really, really works. Okay, but it's not a perfect fairy tale. Like any new tech, MoE comes with its own set of challenges we have to figure out, and its future is still being written as we speak. So, what are the roadblocks? Well, first, getting these things trained can be a bit unstable. And here's the ironic part. While they are cheap to run, they're expensive on memory. You still have to load every single one of those billions of parameters into your computer's memory, even the ones that are just sitting there. And finally, that whole routing process, if you don't engineer it just right, it can actually slow things down a bit. But even with those challenges, the future for MoE looks incredibly bright. The trend is definitely heading towards even more specialized models and some really clever hybrid designs. So what's next? We're going to see a lot of hybrid models that mix the old dense style with these new MoE layers to get the best of both worlds. And get this, imagine deploying just a few hand-picked experts onto your smartphone, giving you super fast, totally private AI right in your pocket. This all leads to next-gen AI assistants that have deep, specialized skills in, I don't know, coding, history, and medicine, all inside one super efficient model. So, if you remember just one thing from all of this, let it be this. Mixture of experts finally breaks that old rule that said bigger means more expensive. It gives us a path to build AI that is vastly more capable and knowledgeable, but in a way that's actually sustainable. Which leaves us with a really fascinating question to chew on. As we look to the future, is that idea of a single giant AI brain a thing of the past? Is it possible that the future of truly powerful AI won't be a single mind at all, but a perfectly coordinated team?